Centripetal force. As this object moves in a circle, it is constantly changing direction, and therefore, as velocity is a vector, it is constantly changing velocity. Acceleration is equal to the rate of change of velocity. Therefore, the object is accelerating. It can be shown that the acceleration is equal to the speed squared divided by the radius. You're not expected to be able to show that in this course. We can write that as a is equal to v squared over r, where a is the acceleration, v the speed, and r the radius. To accelerate requires a force, and from Newton's second law we know that force is equal to mass times acceleration, or F equals ma. So the force required to make an object of mass m move in a circle of radius r, this is called a centripetal force, is given by F equals mv squared over r. As we met on the angular velocity video, v is equal to r omega, where v is the speed, r the radius, and omega the angular velocity. So we can substitute this term to get F is equal to mr omega squared. You're aware of the centripetal force making you travel in a circle on a fast roundabout ride. The outer side of the seat pushes against you, providing the centripetal force needed. Centripetal force acts towards the centre of the circle. Here's an example. A person of mass 60 kilograms is on a roundabout of radius 4 meters and takes 2 seconds to travel all the way round once. Calculate the centripetal force needed to move them in this circle. Well, for this we need the equation force is equal to mass times radius times angular velocity squared, or F equals mr omega squared, and omega in this case will be pi radians per second. One complete rotation is equal to 2 pi radians, so we are doing half a complete rotation in 1 second. Putting in the figures then, the centripetal force is equal to the mass of 60 kilograms times the radius of 4 meters times the angular velocity squared of pi radians per second, giving a force of 2,370 newtons.